So state space variables are very important for our application because all the state space variable will change as the vehicle move in different directions, as well as change the orientation. So let us understand the state space variable first. What are these? So basically, if you have an airship or a vehicle which can move in forward, upward or right and left directions, then it has requirement of velocity components in x, y and z directions. Now x, y, z direction, in conventionally if we define, then the x, y, z direction is defined as x in the direction of the nose of the vehicle and the jet towards the earth, which is in the downwards direction. And with the right hand rule, the y direction will be in towards the plane or inside the plane, which is this one. Now this is based on body, which is our vehicle's body. That's why we can use the subscript as b as a body. So this is the reference frame with respect to body. We also have to define the reference frame with respect to earth, which will be, suppose over here this is earth. So with respect to earth, we will have a reference frame xe for x direction earth, ye for y direction earth, and ze for z direction earth. So similar to the xb, yb and zb. Now we have with respect to earth and we have with respect to body. Now your airship can move in the forward direction and right and left, that is xb, yb and zb direction. So for the xb, yb and zb direction, we have three velocity components: one for x, which is called as u, one for y, which is called as v, and one for z, which is called as w. Keep in mind, towards down is positive, towards right is positive, and towards inside the plane is positive. So this is x, y, u, v, w, the velocity components, or 3 state variables out of 12. U, v, w, one set is ready for velocity. Now your vehicle can have the orientation angular change also, like this is one orientation angular change, as you can clearly see. Now if this is changing or this is changing, then this is changing with respect to center of gravity, and how much it will change, that will be the angle, and that angle we need to define. So for the roll we have phi angle, for the pitch we have theta angle, and for the yaw we have psi angle. So these are three another state variable, also called as Euler angle of the body with respect to body frame. This is with respect to body frame, this is also with respect to body frame. So phi, theta and psi, this is all with respect to body frame, that is angular change. Okay, now after defining the 6 state variable set, we have another variable set which will be like the angular change of the body, how fast it is rotating, that is how fast it can be rotated very slowly and it can rotate fast. So these are the rates of the Euler angle change. So these are the rates also defined as PQR for the body. So P for rolling rate, Q for pitch rate, and R for yaw rate. So basically PQR, roll, pitch and yaw rates. This is also defined in the body frame with respect to body. So now we have defined total 9 state variables. Based on this, we will have a change in position, change in orientation of the body, and how fast it is changing, this we predict. But this is with respect to body. Now with respect to earth, there is some position of the airship, that is this position is there from this point to this point. So now with respect to earth, if we want to calculate the position, we will have to define 3 variables we need to define. Those is xe, ye, ze. So important thing over here is these are with respect to the earth frame. Rest 9 variables were with respect to body frame, and this is with respect to earth frame. Now so these are all the state variables. Why they are called as a state? Because it is representing the state of something, and in space, that is vehicle is flying at some location, so in space it is flying, that's why state and space. So in simple terms, this is how we define state and space. So these 12 variables will be very crucial for us, and we need to have understanding of initial conditions of these 12 variables before going to simulate any vehicle. So we will define the initial conditions of the 12 state variables in MATLAB environment.